Okay, the second subtopic, which is on thermodynamics processes. So in this subtopic, you should be able to define the processes of isothermal, isochoric, isobaric, and adiabatic, adiabatic. Okay, and then you also have to be able to discuss the pressure against volume graph. Right, so the thermodynamics processes, there are 4 processes that we will be focusing on. So the first one is isothermal process. So isothermal process means a process is occurring at a constant temperature. Okay, so that's why the name is isothermal. So iso means they are constant lah. Thermal is the temperature. So for an isothermal process, the change in internal energy will be equal to 0. So when the change of internal energy will be equal to 0, based on the first law of thermodynamics, the heat will be equal to the work done. Okay, so when a gas expands or compresses isothermally, so if the gas expands isothermally, work will be positive. If it is compressing isothermally, work will be negative. Okay, so the next one is a diabetic process. This is a process that occurs without any heat transfer into or out of the system. So this is a process that does not have any heat transfer. Okay, so Q will be equal to 0. Again, based on the first law of thermodynamics, the change in internal energy will then be equal to the negative of work done. Okay, for example, the compression stroke for an internal combustion engine is an approximately an adiabatic process lah. Okay, so if it is expanding, work will be positive. If it is compressing, work will be negative. Okay, so if the work for an adiabatic expansion, the change in internal energy will be negative. If it is negative, the energy is decreasing. If it is positive, energy is increasing in the system. Okay, right. Isochoric ataupun isovolumetric means it is process that occurs at constant volume. Okay, so for constant volume, work will be equal to 0. Okay, so based on the first law of thermodynamics, the heat will be equal to the change in internal energy lah. Okay, so in an isochoric process, all the energy added as heat remains in the system lah. So it causes an increase in the internal energy, hence the temperature of the system will also increase. Okay, so heat remain in the system and then increase in internal energy, hence the temperature of the system increases lah. Okay, for example, heating a gas in a closed constant volume container lah. Alright, last one is isobaric process. So isobaric means a process that occurs at constant pressure. Okay, for constant pressure, there is no change in the pressure, so work will be equal to P delta V. Okay, so based on the first law of thermodynamics, heat will be equal to the change in internal energy plus the pressure times the change in volume. Okay, for example, boiling water at constant pressure. For example, by using a pressure cooker lah. Okay, because the pressure is constant kan dalam the pressure cooker. Okay. Alright, so pressure volume diagram. So this is the graph. So this graph is showing each of the process for a constant amount of an ideal gas lah. For example, if it starts at A lah kononnya, okay? So this purple line here, we are looking at an isovolumetric process. Why is this an isovolumetric process? Is because the volume is constant. There is no change in volume. And then from A to C, or this pink line here, it is an adiabatic process. There is no heat transfer. And then from A to B, this is an isothermal process. This is one constant temperature. And then from A to E here, this is an isobaric process. This is a process that occurs at one constant pressure. Okay, so for comparison between the isothermal and adiabatic, the temperature falls which accompanies the adiabatic expansion causes a lower final pressure than the one in isothermal process here. Okay, and then the area under the isothermal, this is the area under the isothermal, is greater than the area under the adiabatic, which is up until here saja. Okay, so what does the area under the graph means? It is telling us the work is done by the isothermal expansion is greater than the work done by the adiabatic expansion lah. Okay, and then the adiabatic through any point is steeper than the isothermal through that point. Okay, so this adiabatic process is steeper than this isothermal process. Okay, this is just a comparison between isothermal and adiabatic lah. Okay, all right, so that is the theory part for example for example for subtopic 14.2.